In today's class, let's learn about elimination of useless symbols. So before going into the topic, you need to know what is a useful symbol and what is a useless symbol. A useful symbol is any symbol which can generate a string of terminals. Okay. So useless symbols are any symbol which cannot generate a string of terminals. So our question is to identify the useless symbols and to eliminate them. So there are two kinds of useless symbols. One you call it as non-generating symbols. So these are the symbols which cannot generate a terminal at all. It cannot give a string of terminals. Okay, those are called as non-generating symbols. And the second one is not reachable symbols. These are the symbols which we cannot uh, reach from the start symbol. Okay, those are called as not reachable symbols. Okay, not reachable symbols are symbols which you cannot reach from the start symbol. They've given the grammar G equal to VTPS. V stands for the set of variables. T stands for the set of terminals. P stands for the set of productions, and S stands for the start symbol. So there are four variables in this question. They are S, A, B, and C, and there are two terminals. They are 0 and 1. So any variable which can generate a string of terminals or a single terminal, you call it as generating symbol. So if any variable couldn't generate a string of terminal, you call it as non-generating symbols. So they have given a set of production rules. They have given productions for all the four symbols. So S alone has four productions. All the others, they have single production. So the four productions of S are S tends to A double one B, double one A, B, or double B. Okay. So let's see the generating symbols and non-generating symbols. So first, let me take A. Okay. So A is my non-terminal. When I expand this A, when I try to expand this A, I apply the production rule. A tends to 0. So I will expand this A as 0 here. This 0 is nothing but it is a terminal. So I say that A is generating symbol. Because it is generating the terminal 0. Okay. Similarly, I'm going to take my next variable, which is P. So when I try to expand this B, I will apply the production rule of B. So the production rule of B is B tends to two non-terminals BB. So when I expand it, I'll write B as one left child and the following B as the right child. So I can further expand this by applying the same production rule because I have only one production for B, which is B tends to BB. So when I apply the same rule again, B tends to BB. I notice that every time I'm expanding the symbol B, I have only the set of non-terminals BB, but I could not end up in any terminal or a string of terminals. So B is a non-generating symbol. Yeah? So this B has to be eliminated. Now we'll see the other symbols as well. Next, we'll go with C. For C again, we have only one production, which is C tends to 1. 1 is a terminal, so C is generating. So when you construct the parse tree, you will have C tends to 1. As 1 is a terminal, yes, it is a generating symbol. So you write C as generating symbol. Next, we have S. So S has 4 different productions. S has 4 different productions. In all the 4 productions, even if any one is generating, yes, you can consider that S as generating. So if you see from the question itself, you can know that S tends to double one. One is a terminal. So double one is a string of terminals. So S is generating. Yeah. So when you apply this, yes. So if you have more than one production rule for a variable, even if any one rule can help you to generate a set of terminals, then you call it as generating symbol only. Okay. So S tends to 1, 1. This is a set of terminals. So S is generating. We have covered all the variables, right? A, B, C, and yes. So now our task is to remove this non-generating symbol. So when you remove this non-generating symbol, what do you get? Remove the non-generating symbol from the given grammar. So when you remove the non-generating symbol, you will remove all the symbols which have B. So if you see the first rule, S tends to A double one B. So this has B. So I will remove this particular production rule. Then the next one is S tends to double one A. I do not have a B, so I can consider this. Next one is a single B, which is a non-generating symbol. So I have to eliminate this particular one. Then S tends to double one. I can keep double one because it is generating. So in this set of productions, I can just keep double one A and double one. And then I will eliminate A double one B and B because B is non-generating. So I'm removing all the non-generating symbols from all the productions. So similarly, check for the others. A tends to 0, which is generating. Okay. And B tends to double B, which is non-generating because it has 2 non-terminals B. Every time when I try to expand it, I'll end up only in a non-terminal. Next one is C tends to 1. Yes, that is generating. Yeah. So I'm going to rewrite my grammar after removing the non-generating symbols. So you will write your updated grammar. Okay. So your updated grammar will be P equal to S tends to, you will remove A double one B because it has non-generating symbol B. The next production is double one A, or you will remove B because it is non-generating, and the next production is double one. Then you will have A, I'm sorry, A tends to 0. You will remove the entire B production. So you will have C tends to 1. Now we need to identify the not reachable symbols. So not reachable symbols are the symbols which you cannot, or the variables which you cannot reach from the start symbol. So if you see this, S tends to double one A or double one. So in the right hand side, I have only one variable A. So from the production rule S tends to double one A, I can reach the variable A. Okay. So I can reach the variable A. So I'll be choosing the production rule A tends to 0. So in the right hand side, is there any variable? No, there is no variable. So I cannot reach any other symbol. And as a resultant, there is no way for me to reach the symbol C or the variable C from the start symbol directly or through the other symbols which I can reach from the start symbol. So C is called as a not reachable symbol, and we need to remove this not reachable symbol. So you need to rewrite your grammar by removing the not reachable symbol. So the updated grammar will have the production P equal to S tends to double one A or double one A tends to 0. I cannot reach C, so I will eliminate C. So this is the updated production rule after eliminating the useless symbols. So next we'll learn about eliminating the epsilon production. So before going into the topic, let me first tell you what is an epsilon production. So any production which is of the form any production which is of the form a non-terminal tends to epsilon, you call it as an epsilon production. So a non-terminal is any capital letter. So this is called as an epsilon production. Okay. This is how an epsilon production will look. Okay. So I hope you people can now identify what are the epsilon productions in the question. So here I have x tends to epsilon. So x has an epsilon production and y tends to epsilon. So y also has an epsilon production. So our task is to remove this epsilon production by preserving the meaning of the entire production. Okay. So there are three productions in the question given. S tends to xyx, x tends to 0x or epsilon, y tends to 1y or epsilon. So I need to remove this epsilon production from x and y. But it is not possible for me to remove it by just removing epsilon production from the rule. Okay, I need to follow certain steps. So let's see how it can be done. I'm going to consider the first production. S tends to x, y, x. So write the production as it is. Write whatever production is given here as it is. So now what you're going to do is, I'm going to substitute x tends to epsilon, which means that I'm going to substitute epsilon in place of x in the particular production rule. Okay. So first I'm going to substitute epsilon in place of the first x. Epsilon means it's an empty string. It doesn't have a meaning. So if I substitute epsilon in this place, what will happen to my production rule? My production rule will be y x. This will be my production. Yeah, I'm going to substitute epsilon in place of this y. So when I substitute epsilon in place of this y, what will happen is this y will be replaced by epsilon and I will have x and x. Yeah. So I'll have x as my next production. Now, since we have replaced this x with epsilon, we got yx. When I replace this y with epsilon, I got xx. Now I need to replace this x with epsilon. So what are the remaining two terms? X and y. So that will be my next production. Yeah. Okay. So now what will happen if I'm going to apply epsilon for the first x and y? So when I apply epsilon for the first x and y, this x will be replaced by epsilon and this y will also be replaced by epsilon and the remaining symbol which I have is x. So I'll be writing that x as my next production. Yeah. Now, what if I substitute epsilon in place of first x and the last x? So what will happen? So when I use x tends to epsilon, both for the first x and the last x, the remaining symbol what I have is y. So I'll write that y over here. Now I have tried all possibilities, right? I'm repeating. So S tends to XYX is the given production. I'm going to write the production as it is. And I have two different rules here. One is X tends to epsilon and Y tends to epsilon. So I'm going to replace all the X with epsilon and all the Y with epsilon, one after the other. So first what I've done is in place of the first X, I have replaced X tends to epsilon. Okay. So which means that this is an empty string and followed by that I have only y and x. So I'm writing that y and x over here. Okay. So in the second time, what I'm doing is I'm just replacing y tends to epsilon in the same production. So when I replace it, I get x and x because this is replaced by epsilon, which is an empty string. Remaining is x and x. I'm just writing that over here. Yeah. So next, I'm just replacing the last x with epsilon. So when I replace the last x with epsilon, the remaining symbol which I have is xy. So write xy as it is. Yeah. And then I'm going to replace the first x and the first y with epsilon. So the remaining symbol is x. So write x as it is. And then I'm going to replace the first x and the last x with epsilon. The remaining symbol is y. So write y as this. So this is how you will remove, you will apply epsilon for the symbols where you do not have epsilon. Okay. So next one is, we'll go on with the next production. So what is the next production? X tends to x tends to, we have 0x. So write the production as it is. Okay. Or I've just written this production as it is. X tends to 0x, or we have epsilon. So for this epsilon, I will substitute this epsilon in place of x. So when I substitute this, I'll get 0, right? When I substitute epsilon in place of x, I'll get 0. When I substitute epsilon in place of this x becomes null. So what is remaining over here is 0. So I'll write this 0 as an alternative production rule. Got it? And next one is, I must not write epsilon now because I'm eliminating epsilon. Okay. So the next one is y. So we have y tends to, write the rule as it is. Y tends to 1y, or I will not write epsilon because I'm eliminating epsilon production. So instead of that, I'll replace epsilon in place of y. Y tends to epsilon. So I replace epsilon in place of y. So when you replace epsilon in place of y, it is 1 epsilon. Epsilon doesn't have a meaning. It is an empty string. So remaining part is 1. So you will have to write that 1 over here. So write that 1 over here. Yeah. So thus we have removed the epsilon production. So next topic for today is elimination of unit production. So how do we eliminate the unit production? So before going into it, we'll first see what is a unit production. Any production which is of the form a single non-terminal tends to a single non-terminal, you call it as a unit production. Okay. So any production which is of the form one non-terminal tends to one terminal, non-terminal, which is one capital letter tends to one capital letter, you call it as a unit production. Okay. For example, it's like x tends to y. Here, x is a non-terminal and y is a non-terminal. One non-terminal tends to single non-terminal. You call it as a unit production. So in a CFG, we need to remove the unit production. So let's see how it can be done. Okay. So before that, let's see the question. So here they have given the grammar. We need to first identify what are the unit productions. So if you see the question, you can identify the unit productions in the grammar. Unit productions in given CFG. So what are the unit productions in the given CFG? S tends to 0A. So this is one terminal followed by one non-terminal. This doesn't satisfy this format. Next one, S tends to 1B. This is again one terminal followed by one non-terminal. This also doesn't satisfy the format. Next one is S tends to C. Yes, one non-terminal tends to one non-terminal. So this is a unit production. So make a note of it. S tends to C. It is a unit production. Yeah. So next, A tends to 0S, one terminal and one non-terminal. So this is not a unit production. A tends to 00, both are terminals. So this is not a unit production. B tends to 1, it is a terminal. So this is not a unit production. B tends to A. A is a non-terminal, single non-terminal. So this is a unit production. So you have one more unit production here. A tends to, B tends to A. Yeah, you have one more unit production over here. B tends to A. So next one, C tends to 01, which is a set of terminals. So in the given question, there are a unit production will be in this form. One non-terminal tends to one non-terminal. Okay. So in the given question, there are two unit productions. S tends to C and B tends to A. So we need to eliminate these both unit productions. So in order to eliminate a unit production, you're going to substitute the right hand side or the expansion of the particular variable. So if I see S tends to C, okay, you need to check what is the right hand side or what is the expansion or production rule of C. So we have a production rule C tends to 0, 1. So what I will do is in place of C, I will substitute this 0, 1 in the given production. Similarly, B tends to A. So in place of this A, I will substitute the production rule of A. So what is the production rule of A? There are two production rules, 0S and 0, 0. So in place of this A, I will substitute 0S and 0, 0. This is how we will eliminate the unit production. So let's do it. So I'm going to first eliminate S tends to C. So let me rewrite the grammar. S tends to, what is the first rule? S tends to 0A. So write it as it is. Okay. Or what is the second rule? S tends to 1B. Write that also as it is. S tends to 1B. Or third rule, S tends to C. S tends to C is a unit production. So I have to eliminate this S tends to C. So in that case, I will check what is the production rule of C. The production rule of C is C tends to 0, 1. So I'll substitute this 0, 1 in place of the C. Okay. So when I substitute it, I will get 0, 1. So I will not mention C here, but instead of that, I will mention the production rule of C over here. So now I have eliminated the rule S tends to C. Now I need to eliminate B tends to A. Okay. So in the production rule of A, there is no change because there are no unit productions. So write whatever production rule is given in the question. A tends to 0S or 0, 0. So write it as it is. Okay. Then you have the next rule. B tends to. So what is the first rule of B? The first rule of B is B tends to 1. So write it as it is. So B tends to 1. Or what is the second rule of B? Second production rule is B tends to A. Here, this A is, B tends to A is a unit production. I need to eliminate this. So in order to eliminate this particular A production, I have to replace this A with the production rules of A. So I have two production rules. A tends to 0S and A tends to 0, 0. I will replace this A with these two productions. So let's write it. So instead of A, replace 0S, which is the first production rule of A. And then you have one more production rule, 0, 0. So replace that in place of A. So thus we have eliminated the unit production B tends to A. So now we have one more production. So which is the production rule of we have one more production. Yeah. So it is C tends to 0, 1. There is no change in it. So write it as it is because it doesn't have any unit production. So this is how we will eliminate the unit productions. Let's summarize what we have learned. We learned about what are useless symbols, how to eliminate the useless symbols, then we learned about what are epsilon productions, The other name for epsilon production is null production. Then we learned how to eliminate epsilon productions from a grammar. Then we learned about what is a unit production and how to eliminate the unit productions. These steps, elimination of useless symbols, elimination of epsilon productions or null productions, and elimination of unit productions are the basic for converting your grammar into a CNF. That is your Chomsky normal form. Thank you.